Record is rolling. It is Friday, September 5th. Your quizzes are back in your phone. Actually, everything you've done up to yesterday is scored, is returned, it's back there. So, yeah, it's quiz corrections. Quiz corrections. Here's the policy on that. If you have any questions and you want partial credit back, then on a separate page of paper, write how to get to the correct answer. Now, there's different kinds of questions that with different kinds of solutions. So if something's an equation and you can set up and solve an equation, then again on a separate page of paper, set up and solve the equation. If you drew an incorrect graph, then just draw the correct graph. Right? Straight edges, rulers are good to draw axes. Right? Draw the correct graph. Every once in a while, there might be something conceptual. Like I asked you guys, one of the questions was that what's the base SI unit for mass? Now, something like that, you just maybe write out the answer because can't really show your work. But if you can show your work or draw a graph in some way, then do that. And then if as long as it's correct and you show me you know how to get the correct answer, I'll give you partial credit back for anything you missed. Okay. So any questions about partial credit or quizzes? Partial credit backs? Okay. Ooh, add this STEM flyer. All right, so it's like a club. This is I think in Mr. Dolan's room after school on Mondays. So if that looks interesting to you, got a STEM club going. Okay. All right. And you guys, AP, guys, what's due by the time you come to class on Monday? Yeah, AP classroom. Now there are a few things open, but I think there's only one with a due date, and that would be, of course, this coming Monday. Right? It's guys, AP classroom. There's one. There's an assignment. I think it's a progress check unit one. Okay, progress check unit one, which is linear motion and projectiles, and we'll do some projectiles today. Okay. Actually, I want to give you guys a hint on one of those questions. Okay. All right, so you guys know Unit 1 progress check on AP Classroom is due over the weekend. Right, so by the time you come to class Monday, because I want to go over the answers on Monday. All right, let me find a Paul Hewitt. Yeah, it'll be completion. All right, Paul Hewitt.
We have a little device here that will shoot a projectile. Little spring here. I'm going to compress the spring. And when I do that, I can put a projectile here and watch this, gang. Little spring gun. Out it goes. No surprise. But I've got another ball that I can put on the end here like this. And when I go like this, it falls essentially straight down. A little bit out, okay? But kind of downish. This one goes outish. Now I'm going to do them both at the same time. When I do them both at the same time, you guys got to figure out, hey, which one going to hit the ground first? The one that just dropped down or the one that just goes out?
Aha. There's the question. First, you gotta do an experiment. You guys see? All right. So, uh, recap what you just said. He's got these two balls, like these two bearings. When he hits the spring lever at the top, boing, the one on our left, so I'll just call it on the left side, falls pretty much just straight down to the tabletop. And the one that I'll call on our right side over here is going to shoot straight out horizontal. And then it's going to follow what kind of path? What shape path? A parabola, right? Parabola path. And maybe hit the tabletop way off screen, right? Way off to the right, right? Now, which one hits the tabletop first? Is it the one that goes straight down, the one that goes straight out and follows a parabola, or do they hit the tabletop at the same time? See, show of hands. What do you guys think? Show of hands. How many of you guys think the one that falls straight down is going to hit the tabletop first? Who thinks the one that goes straight out, horizontal? That one's going to hit the tabletop first. Who says they're going to hit the tabletop at the same time? Oh, look, I think that's everybody. Is that the whole class? Is that the whole class? Wait, how'd you guys know that? Sick.
Goes out. A lot of people think, well, when it's fired out, it's going to be in the air for a longer time. You know why? Because gravity is going to start to pull it and say, oh, I didn't know you were moving. Go ahead. And gravity not going to pull so hard. What do you guys think? Let's try it. I tell you what. If you hear this, all A's. All A's. For this course, all A. Registrar say, Hewitt, my God, Hewitt, you got all A's in your class. I'll say, I had a sharp class, honey. I had a sharp class, all right? All A's. But if you hear this, then you gotta do your homework, okay? Here we go again. Here we go. This next moment may be very important for a lot of you who are everything riding in your grade. All right, here we go. Here we go. Listen.
Uh, it was the same time, just like you guys said it was going to be. Yeah, everybody remembered it. You guys remember, if you blast something out horizontally, you drop it at the same time, had the exact same vertical motion, doesn't it? Same vertical motion. Yeah. All right. You guys remember that? Awesome. Awesome. Right. So the main thing we're doing today is, you guys remember this page I handed you guys yesterday? Okay. Oh, get as far as I can with that. Right. But before we get to that page, there is, well, okay, on AP Classroom, there's one question I thought was particularly tough, so I do want to help you guys out with this. Okay, and it's one that goes like this. Right, so it's number 15. So the premise is there's some guy with a golf ball right, next to a very tall building, like several floors up. He's gonna take his golf club and hit the golf ball, pop. Right, some speed at some angle. Guys, some speed at some angle. What's the physics term for that? Starts with a V. Velocity. Right? So velocity is speed, but also angle. Speed direction, isn't it? Okay. And then the ball is going to follow what kind of path is this called? Yeah, parabola. And it's a point to the building. Okay? Now, I forget exactly how they phrased it, but in some way they said it would bounce straight back. Boing. Okay, so, guys, when it's hitting the building, it's actually moving strictly horizontally just at the very moment it happens to be striking the building face. You guys get that? Okay. And if that's true, then what point does this have to be on the parabola? Vertex. The vertex. That would definitely be the vertex of the parabola, wouldn't it? Just to cover this up. That's right. Okay. Vertex of the parabola. Okay. Now, that is important to solving this, okay? Because if that wasn't true, this would work out a little bit differently. Okay. So vertex of the parabola right here. Point. Okay, you guys good? Okay. So it's at some speed I'm going to call v. At some angle I'm going to call theta. And there's also the distance to the building, this horizontal displacement, I should call it. I'll label that x, right? I guess if you wanted to, it could land somewhere up the face of the building. You could label that y or h, but I'm not going to do that because it ends up not helping you solve it. So simplify, I'll strip that a little bit. Right? But it does land some distance y or h. In fact, I've actually sketched out 3 paths. You guys see it in blacking at this middle path? But guys, what if you hit it a little bit harder, but at a shallower angle? Could it be the peak of very shallow parabola right here? And what if he kind of lobs it at a steeper angle? Boing? Could it possibly be the vertex of a parabola here? Yeah. So where it lands up the building kind of depends on how hard he hits it at what angle. And but it could be a multitude of locations. It could still match the conditions that they gave you where it bounces point straight back. Okay? Okay, you guys good with that premise? Okay. Now, there are no numbers on this one. It's all variables. Okay, there are no numbers here. It's all variables. Okay. Do you think gravity field is going to enter into some kind of equation? Yeah, because if there's no gravity, what would the ball do? So, fly into space. Okay, so gravity field does matter. So I have to follow that arc. Okay. Now, since we're in projectiles, you have to focus either strictly on what's going horizontally, like across, or strictly on what's going vertically, like up and down. And those would be sort of separate from each other, right? Okay. Except for the amount of what? To go from here to here, it's the same amount of what? Same time, right? Different vertical displacement, different horizontal displacement, different velocity, vertical or horizontal velocity, but it's the same time whether you analyze it vertically or horizontally. Okay, great. So that's important too. That's part of this. But you have to set up separate equations. So there's going to be a vertical equation and a horizontal equation. Okay, you guys get that? Right, roadmap here. Okay. Now, I'm going to show you. I don't know if this is going to be too much, but I'll show you quite a bit here. What I want you guys to do ideally is when you go home and you get on number 15, you're like, oh yeah, that's the one with the golf club and the golf ball in the building. Okay, pull out a blank piece of paper and see if you can solve this whole thing from scratch. Okay, just on a blank piece of paper. And if you get really, really stuck, then you'll have the notes that I'm about to give you right now, or this video for that matter, because you guys don't get this video. Okay. Okay. Now, guys, in the horizontal direction, there's only ever one equation for projectiles, and that goes how? X equals. Okay. Guys, does gravity pull horizontally? No, gravity only pulls vertically. And is gravity field a type of acceleration? Yes. Gravity field is an acceleration. So if there's no acceleration, then, well, these bottom two don't look very useful. If you knock out this A is equal to 0, okay, the velocity just stays the same. Right. Okay, and if this goes to 0, oh, you guys remember that one? X equals vt? Distance equals speed times time? Okay, so guys, when we're working projectiles, You guys know the ball goes across the field at a constant speed, like horizontally speaking, right? Right? It's just x equals v sub x times t, right? Okay. Where v sub x is the velocity um, in the horizontal direction. Okay. Okay. So is that okay where that has to come from? Okay. I mean, you could almost make that without much thinking because that's the only thing you think. Okay. Now, vertically, you guys know vertically it's a bit more complex because, well, all these equations open up vertical. Now, for the next few days, I'm going to change this general displacement that I'm calling x on this poster to either a y or an h. Is that okay? It could be a y or h for like vertical, right? No. Right. Now, you could use, I mean, this or this or that. How do you know what to use? Right. I'll give you guys a hint here. Oh, right. The fact that we're juggling two equations and it takes the same time. And if you look at the answer choices for whatever question, they want you to link all these variables to say what's the relationship between how far it goes to the building, how fast it hits at v, and at what angle theta. Right? There's some expression they want you to come up with to link these variables. Okay? What's a variable that I did not mention? If I pointed at x, v, and theta, what variable do you not see? Time, which is maybe a hint that you maybe want to substitute out the time, right? Does that make sense? Because if time has to show up in this equation, but it doesn't show up in the answer, do you think you have to substitute it out at some point? Okay, make sense? Okay, right. Thinking big picture here, big picture. Also, is if this is the vertex of the parabola right here, vertex of the parabola, I'm thinking back to vertical now. What do you know is the vertical component of velocity at the very top? Zero. Because when this ball is hitting the building face, it's not moving up or down for that very instant. Right? It's only going to the side. Right? So with all that in mind, which equation am I sort of leading you guys towards for the vertical direction? So something about time you want, so you can substitute it out. Something about vertical component velocity goes to zero. That's got to be which one? This one here. Right? Now, you could make an equation for like where it lands up the building, but that could be different. So you could call this y, but it kind of leads you to a dead end, or I don't know, maybe this way to solve it. Right? This last one doesn't say anything about time. Okay. Yeah, let's do the second one. Right? So I'm really helping you guys out here. Right? So you do, is that okay? So v final in the y direction equals v initial in the y direction minus gt. Isn't that like a modified version the second? Right? But you guys know vf in the y direction is going to be equal to what at this point again? Zero. Right? So it's the version of the parabola. Right? And something else. You know what is actually a good first step to do that I totally skipped over? Right? For this type of scenario is whenever you see a ball being thrown or hit at some angle, at some speed at some angle, first thing to do is to break that into components. Say, how fast is it going across the field toward the building? And how fast is it going strictly up? Which, of course, is going to be changing as gravity is pulling through the air. Right? And what would those be? Here, I'm covering it up. Let's start with this one down here. Guys, what expression am I covering up right down here? Yeah, v times cosine theta, right? V times cosine. So v sub x is v times cosine theta. Right? And what about this one over here? V initial in the y direction. Guys, initially in the y direction is equal to v times what? Sine theta. D sine theta. Okay? Right, all right? Could that go in right here and right here? The cosine component and the sine component? Is that okay? And that gives you expressions that look like this. Okay? Do you guys see where this is all coming from? Right? Again, I don't know if I'm telling you guys too much, but I see a t here and a t here. Could you rearrange one of these in terms of t and substitute it into the other one? Could you do that? Okay, great. I'm getting you like 80% of the way there. And now there's a few algebra steps after that, but that's the main physics. Okay. Again, I thought that one was kind of tough. See if you can, when you see the golf question in the building, okay? See if you can solve that all just from a blank piece of paper. Okay? All right, you guys see that? All right, it is H time. So let's look at these projectiles. Projectiles right here. So what we got? So organization of stage. So these three scenarios on the left side, you could draw a picture that looks like this poster where there's a cannon firing horizontally off the edge of a cliff. That's all these three scenarios. Now I give you different kinds of information, so there's different ways to solve these. Okay? But this is the picture. That's the basic premise. The three on the right side is a different picture. Let me find a different picture. Found it. Found what I'm looking for. It's going to be more like, okay, these three on the right, you have a cannon. Oh, okay, on a giant plane, and you have the cannon ramped up at some angle and blast the cannonball. Okay, so that's the basic premise for these three on the right. Okay, on the back side is a hybrid situation. Do you guys see there's yes a cliff, but also there's a blast angle, right? It's put together. And the scenario on the left side, I'm helping you guys out a lot, so I'm leading step by step by step. Okay. So we'll get as far as we can today. Start with the second scenario. You guys see the second scenario right here? So cannon fires cannonball horizontally off the cliff. Okay, I gave you the cliff height on this one. Oh, remember how I gave you the horizontal information here and the vertical information over here? You guys remember that? Okay. Now, you guys know in most physics textbooks, they're not going to conveniently give you these tables, but how do you organize the information? Okay. Okay. So find how much time does it take for the cannonball to reach the ground? How far from the base of the cliff does the cannonball land? And there's a couple questions that go together, how to do with the crash velocity. So this is number 5 through 8. Number 5 through 8. Okay. You guys know I make like 10 different versions of this paper. So my numbers are probably different than your numbers, unless you're really lucky today. But here's a cannon, edge of the cliff, and it's going to blast the cannonball at some blast speed, blast velocity, and that cannonball's going all the way down to the ground, following that nice parabola shape, just like you guys said it would be a parabola, right? Like that. Okay, you guys go with that? Okay, so what do I know here? I know, guys, I know the blast speed of the cannon, which is also, would the blast speed of the cannon for this particular scenario also be the horizontal component of velocity all the way across? The same thing? It is. Because v blast equals v sub x, as long as you aim it horizontally, okay? Next week, this is going to be one of your labs. We'll take the launchers out to the balcony out here, and we'll do something pretty similar to this. Now, on my paper, it says this value is 90 meters per second. It's probably different on your paper, but I'm getting that from right here. This is v sub x. I gave you guys acceleration. So g equals 9.8 meters per second squared downward. Okay, like that. Okay. And then, I gave you the height of the cliff. Mine says 13 meters. Yours, again, probably says something different. Okay, so the height of the cliff right here, I'll call it h. No, is that what I call it? No, I called it y here. YH. I think it's right. 13 meters. All right, and that's the starting premise. Right. Is that what you're for? See that? Maybe. I think. Yeah, put some down. I think. Letting motion passes. What if I gave that okay, so you guys good so far? Okay. Now, what should I start with here? Should I start with vertical information or horizontal information? What do you guys think? Horizontal. Let's see. Okay, yeah, I'm going to start with vertical information. What was the first question? Was how much time, right? How much time does it take to reach the ground? Okay. Because here's another hint why you start with vertical. Do you see? Here's my horizontal. Here's my vertical. Do you guys see that there's a bunch of information stacked up on vertical? Actually, there's 3 kinematic values that you know. Okay. Versus horizontal, not so much. Okay. We don't have enough to solve anything yet. Right? Now, we will later when we start solving stuff. Okay? In fact, guys, all these variables are vectors, which is to say that they matter either strictly horizontally or vertically, except for one, because time. Time is a scalar. So guys, if you solve time from here, can you just very simply transfer that time over here? That's how we're going to get time and eventually be able to solve all the horizontal stuff. Aha! We're going to do a time transfer. Is that? So whatever we get here, we'll transfer right over there. And then we can solve horizontal. But we have to start with vertical. Okay. Now, where's my kinematic equations? Okay. Oh, which equation do you think would be good to start with for vertical? We're trying to solve for time, right? Ball time? Top one? No, top one? I do too. I do too. Okay. Okay. Here's why. I'll knock out the other ones. If you thought the third one, well, the third one doesn't let you solve for time, so that one's out of the question. Okay. The second one, you're going to run into a dead end. Here's why. Okay. You know the initial in the y direction, which by the way is equal to what? 0, right? That cannonball leaving the barrel, it's not moving up or down during the first nanosecond. So this would be 0. That's okay. Okay. You know G, or this A would be G, right? 9.8 meters per second squared. You don't know time, which we're solving for, but you also don't know anything about the crash velocity. So that would be 2 unknowns. That's why you can't really use the second one, at least yet. You can't use it yet. That first one, we use the first one. So pull the first one. Now straight from the poster, it looks like some displacement equals initial velocity times time plus 1/2 acceleration times squared. That's straight from the poster, isn't it? Okay. We're going to modify it for this situation. General displacement. Guys, I'm talking about what displacement on this picture? The height of the cliff. The height of the cliff. So, well, as a variable, I could call it h, right? H. Right? This is the initial in the y direction, right there. Times. Okay. And then, okay, it's okay if I just call gravity positive, so like down is positive for this one. That might change later, but I'll call this plus 1/2 g, and then t we're solving for squared. Okay, you got it. But since you know that initial velocity in the y direction is just 0 meters per second, doesn't that just knock out that middle term anyway? Okay. So do this then. Flip my paper and solve those two ways. In terms of variables, now it looks like this. H equals 1/2 gt squared. Or if you plug the numbers in terms of h, I'll put 13 meters equals 1/2, and in place of g, I'll put 9.8 meters per second squared. And then we're still solving for t. I want to know how much time does it take. Okay? You guys get that? Oh, right. So here's variables on the left. Here's numerical values on the right. But you guys see these are the same thing. Okay? So can you do the algebra and finish this out?
Yes.
Okay. Go ahead. Go ahead. I'll do it. You guys do it. Okay. So. Equals 13, and at 1.2. Okay, is this working out for you guys? You guys are getting are you guys getting an answer choice on your paper? Okay, I got 1.63 seconds for my cliff. And oh yeah, that's totally an answer choice here. So I just answered number 5 on my paper. You guys get number 5 on yours? Hold on a minute. Hold on. Does this look familiar? Where have you guys seen this? Huh? Huh? Reaction time? Hey, that was the last thing you guys did yesterday. It's the my screen's frozen. Yeah, it's the same thing. It's the same thing. It's the same thing. Yes. Same thing. You guys seen that before? Yeah. So now that we got the time, I know how much time it takes to get from here to here. Here, I'll go ahead and write that. All right. Say t equals 1.63 seconds. Okay, so I solved that. So I know that. I have to figure out, the next question is, how far from the base of the cliff does this cannonball land? So I'll call it x. Or sometimes you see d, or x. You might see either one of those. Right? So, guys, how can you solve how far it goes? X equals what? there's only one equation in the horizontal. Yeah, v sub x times t. Right? And v sub x, what is that according to what I gave you? Is that the blast speed of the cannon? Yeah. So for me, it'd be 90 meters per second. And then, we just found time. Oh, good. And my time is this much. So I'll pop in right here. This many seconds. So it's going across the field this fast for this much time. Oh, now I can know how far the cannonball goes horizontally. Right? Try that out. So I'm getting about this many meters. Let's see, is that an answer choice on my paper? It sure is. That's an answer choice on my paper. Oh, yeah. We are winning. How about you guys? You guys winning? Yeah, everybody's winning. Okay, ready for our next questions? Okay, so number 7 and number 8 kind of go together. Number 7 says what's the vertical component of velocity at the crash point, and number 8 says what's the total speed at the crash. So what's the crash speed? Okay. So you have to get number 7 to get number 8. They go hand in hand. And on my picture, I'll show you guys how I could draw that. Okay. So here's the cannonball going across the field. Okay. And remember, this pink dash curve is a parabola. You guys know that. And this is the vertex of the parabola up at the point of the cannon. Okay. Now, see how I'm holding my ruler flush to the curve, and it starts out exactly horizontal? Okay. If I follow, like, flush to the curve, okay, like, what's the slope of the curve? See how it's getting, okay, so it starts out flat, and it's kind of shallow, and it gets steeper, steeper, steeper. And then here it is at the crash point. Okay, see at the crash point, it's coming in kind of at that angle right here. Okay, see that? So I'm going to draw that. This will represent my crash velocity. Okay, so I'll call that v sub crash. Okay, v crash is coming in like that angle. Okay, see it's like flush to the curve, right there, bam. Okay. Now you guys know for projectiles, should I break this into components? Say how fast across is it going? How fast down is it going? I should do that, right? Can you guys break that into components? Dash, 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 dash. Dash, 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 dash. Break it into components just like that. You guys do that? Okay. And, what else do you know? Ooh. Guys, what is this component right here equal to? Is this? Is that the same thing? That's the same thing. It never changed. And for me, it's this number. Okay? Guys, the blast speed, well, it was horizontal. It's always going across the field at that speed. So the v sub x is always that. Is that okay? Now, this component, I'm going to call v final in the y direction. V final in the y direction. And I don't know what it is yet, but that's what we're about to get. Okay? Now, I have a couple of options, I think, at this point. You guys know gravity's pulling down. That's what's speeding it up. They can go faster, faster, vertical. Okay. We have a option here. You can either get how fast as a function of how much time it's been falling for, or you're allowed to get how fast as a function of the height of the cliff. Either way, it'll tell you the same thing. What do you guys feel like using? The time? Okay, let's do it in terms of time. Again, you could do how to let's pick it. Let's do time. So, in terms of time. So I'm going to say v final in the y direction equals v initial in the y direction. Can I say plus gt? Is that okay? Yeah. Okay. And guys, what is this number right here? 0 meters per second, because it was not moving up or down at the block point. It was only moving to the side, so this must be 0. Okay. We're solving for v final in the y direction. This will be number 7, by the way. It's number 7. Will be answered by this. Okay. I'm looking at 9.8 meters per second squared for, what's my time? 1.63 seconds. 1.63 seconds. Just like that. So what's 9.8 times 162? I'm looking at that rounds to 16.0. Yeah, 16 what? Can I just say 16 and walk away? 16 what? How do you measure velocity? Meters per second. Actually, you guys have been pretty good at units so far this year. So yeah, units, right? Guys, real fast, I'll try it the other way. Could I say V final squared equals V initial squared plus 2GH, right? Goes to 0. V final is the square root of 2GH. This should tell me the same thing, shouldn't it? So square root of 298, and the height of my cliff was 13 meters. This will be some number of meters per second. Pull that out. What's the square root of 298, 13? See if you guys are following. You guys see this expression down here? When I hit enter, what does my calculator have to say? Make sure you guys know what I'm doing. 16! Yeah. Okay, this better be this. It better be the same thing. Because this is just a different way to do it. Let's see if it is. Is it? Is it? Hey! It is! It is! Oh yeah! Physics is winning! Oh yeah! So you guys get the answer to number 7? Number 7, right here. Bam. Number 7, see the answer choice. That work for you guys too? Right. So we're coming in on the close. There's one question remaining on the page, which is, okay, so we know this is this many meters per second. Okay. Is what is the total crash speed? That's to say, if somebody has a radar gun and they point it at this cannonball right before it hits the ground, so right as it's about to hit the ground, what's the total speed? And how would you solve that?
Like cosine sine.
Ooh, that's an interesting thought. Actually, I might come back to that. Oh yeah, what do you think? Yeah, that's what I'm looking for. Pythagorean theorem. Pythagorean theorem. Okay. No, hold off on sine or cosine because we don't know this angle yet. But I'm glad you mentioned that because I do want to go back and revisit what is this angle, but we can't do that yet. So let's do yeah. So crash speed. Let's do v crash. Yeah, this is straight Pythagorean. It's the square root of a squared plus b squared. So for me, that'd be this many squared plus this many squared, the square root of that entire inside expression. Okay. So what is the square root of that squared plus that squared? Okay. Okay, you guys get that? You guys get that too? Okay. I'll tell you what, before I hit enter, I do have an estimation of what a reasonable answer would be. That's a good thing to do. Guys, in physics, should you always have a reasonable answer in the back of your mind? Like yesterday, if you were getting reaction times of like 2 seconds, like, hold on, there's something off here that can't be right. Right, like 0.2 seconds, huh? Right, must admit. Right? Okay. So, guys, if you have a skinny triangle where one leg is much, much bigger than the other leg, the hypotenuse is going to be just a little bit bigger than this one. So this is probably going to be like 91. Okay, let's see what it is. Yeah, it is. 91.4 meters per second. Okay, that's crash speed. 91.4 meters per second. Okay? Okay, guys good? Guys good so far? Okay. Yeah, and I'm glad you mentioned the angle because I do want to have you guys solve for this crash angle. So theta equal, so I'm talking about this theta right here. This theta, okay, this angle from the vertical. What's one way to solve it?
Inverse tan.
Inverse tan? I like that. Inverse tan. Inverse tan of whatever what. What's opposite and what's adjacent? Yeah, 90 over 16 meters per second, meters per second. Okay. You guys do see my picture is not really to scale, right? Okay. Like if it's coming across at 90, but only down at 16, it's really coming in a fairly shallow angle like that. Okay. So I think this angle is going to be, I'm going to guess maybe 80 degrees. Is that more reasonable? If it's coming in like, if this side is actually 90, this height's only 10, sorry, that's 16. Okay. Let's see what this is. What is inverse tan 90 on 16? I'm getting, oh, actually it is 80. It's 79.9. 79.9 degrees. Yeah, like that. Okay. All right, so you guys get on that one? Any questions on number 5 through 8? 5 through 8. Okay. Of course, I'll post this video later and you go revisit that. Okay. Let's do another scenario. Let's skip all the way down here to the bottom right corner. So number 18 through 20. You guys see 18 through 20 down here? I got a cannon fires a cannonball at a castle wall. Let's see how we're doing on don't have time. Yeah, what's okay? Yeah, okay. We'll at least set this one up. The cannon is given horizontal displacement x away from the base of the castle wall and strikes some vertical displacement y up the wall. I did tell you how much time it takes to reach the wall. Looks like somebody brought in a medieval stopwatch. And I told you how far away. I told you the height of the wall, or that it lands, and I told you gravity field. So what's the firing speed of the cannon? And what's the angle that the cannon is turned above the horizontal? And also what's the crash rate against the castle wall? And so I won't have time to solve this whole thing, but I can at least set it up for you guys. So this is number 18 through 20. Let's go. Big old field right here. Big old castle wall. Here's a cannon ramped up at some angle. Here, take this to the board. Blast the cannonball. I'll just call this V for the blast bait. Or no, call it V blast. How about V blast? Okay. That's gonna strike the cannon. Strike the top of the wall, maybe like right there. Maybe it does something like that. That looks fairly reasonable. Okay. So I'll call this vertical displacement Y to match the paper. And I'll call this horizontal displacement X. That's how far from the castle wall. Okay, you guys good? Okay. So looks like I gave you enough information. You could start either with the horizontal here or the vertical here, because I did give you the time, right? I gave you the time. Okay. Okay. So in the horizontal direction, I could say X, this X right here, is equal to V blast times, because V blast times what? Not one more thing. V sub x equals V blast times cosine theta. Okay. So I need a cosine theta here. Okay. And then times t. Okay. In the vertical direction. Vertical. Okay. So separate idea. Vertical. Okay. I could say this y. Okay, so where it lands on the wall. Okay. Equals okay, well V naught y is like V blast times sine theta. Okay, so that's my initial velocity in the y direction. Okay, equals V blast sine theta times t minus 1/2 gt squared. Okay, is that true? Just like that. Okay. So what do you know? What do you not know? I told you x, so check. You have x. You do not know v blast, so maybe we'll put a star. Do something like that. You also don't know this angle. Star. Great. I did tell you the time. Check. Okay. And over here, you know where it lands on the class wall or what the target would be. Check. Okay. You don't know v blast. Solve for that. You don't know the theta. You solve for that. You know time. Check. You know g check. Check. Okay. So do you guys see a system of equations where with two equations and two unknowns? Do you think you could solve that? Solve that maybe? Okay. All right. Yeah, I'm about out of time, but that'll get you guys going. So this will be due about the end of next week. Yeah. Okay, guys. What that is where's my guys? This equation right here is the first kinematic formula. Okay. We're doing strictly vertical. So for some displacement, I put y for vertical displacement, where it lands up the wall. The v initial is this component right here. It's not the full blast speed. It's the vertical component of the blast speed, which is v blast sine theta. And then this t is this t. Okay. And then where I say plus half at squared, well, guys, if you blast the ball sort of upish and gravity's pulling downish, does there have to be a negative sign somewhere in your equation? There has to be, because there's opposite directions going on. Right? You're blasting the ball up, but gravity's pulling down. So somebody has to be negative. So I called down negative, and I called up positive. Okay? So you blast the ball, because otherwise, guys, if you put a plus here, if you put a plus, then the ball will be rocketing into space. No, that's not what's happening. Okay? Okay. Oh, yeah. Got some crazy wizardry going. All right, so yeah, that'll get you guys started. Yeah, you guys have AP Classroom done by the time Monday rolls around, and we will go over those.